Hello YouTube, so it's December and that means it's time for Advent of Code, and I am doing all of them on my private GitHub account, but I don't intend to do videos on all of them because they're not all equally interesting for video content, I think. But this one on day 7 I thought was quite interesting. So I will skip all the text. The idea is basically that you get this long list of output from like a fake terminal, and you have to pass that and do some operations. So in the first task is to what is the sum of the total sizes of those directories that are at most 100,000 bytes. So it works just like a Linux or Unix directory or Unix terminal, that you have the cd command and ls and things. So we'll have to go through this list and pass it. So there's two data structures I want to use. So we see here that we will change folders, and we will also go back, go one folder up, which is kind of like undo the last step. And whenever you have this kind of undo functionality that you require, you should basically think that you want a stack. A stack is a data structure where you put something in, and you can put something in and you can take something out, and the thing you get out is the last thing you put in. So it's like a last in, first out data structure. And in Rust we can just use the vector data type for that, because crucially it has this push and pop data types, which will append an element to the back of the collection and remove the last element from the vector. So that's exactly what we want. We can also, if we wanted a queue, we could use this vec-deck thing instead. But we just want a stack, so this is perfect. So to handle these commands, now let's specifically talking about the cd commands. We're going to maintain a stack that tells us where we are right now. So first of all, I always do this. Let's put this into a let's make another folder that we call data, and this will be day 7, and we'll put it into test.txt. So let me call make directory first. Yes, and copy that, paste it. Okay, and while we're at it, we can do the same for the input. And there we go. Okay, so I have just this single cargo project for all of the Advent of Code days, so I want to kind of organize it a little bit. So let's make a module for each day, and we'll do that here. And then we'll make a function we call part 1. So first we need the input, and we'll simply use this function. And let's see if this works. I'm not entirely sure that it will work. We call it data, day 7, test.txt. And for now we will just check that this actually works. Let's open the main down here, zoom in a little bit. So I want to now do day 7, part 1. Let's run that. Okay, so I forgot that this is a result type, so I'm gonna unwrap it. And it's a private function, so we have to make it public to use it here. Okay, so that worked without problems. Great. So these relative paths are preserved because, you know, when Cargo compiles it, it puts the executable at a different place than the source folder. Okay. So now I want to get out all the lines of commands, and then I just want to handle these cd commands. So let's do something like this. And usually it's a good idea to filter out empty lines, so we can do like that. And now let's make this directory stack that I was talking about. It's going to be a vector, and we'll loop over the lines. And then we can do this kind of trick. We can say line split on space. And then to do pattern matching, we have to collect it into a set of strings. And then we have to call a slice on that. So it's a little bit cumbersome compared to like Haskell or Python or whatever. But at least we see all the kind of operations that are happening. So if we have a $sign and we have a CD and we have like a folder, then we want to handle that. And let's put it to do. And anything else, maybe I can just write other. We will skip it for now. Won't do anything. And good. So what do we need to do? Well, we basically need to add this folder to the stack of directories. So we will say, and this one has to be mutable, by the way, push folder. Now it would also be interesting to see what is the current folder. So let's do that out here, just for debugging purposes. Current folder. And let's just do this for now. Oops. So this will not work correctly, but let me just run it to okay, that didn't work. Okay, I think the problem is that we are using this value. So let's toString it. So this will be a vector of strings. Let's see if that works. So that works. And you can see it's printing the folder for every line in the output, in the input. So that is also printing the input, which I guess we can remove now. Let's run it again. But you can see it tracks the folder. But this is like just the kind of the local folder name. So we don't actually know if this folder, this D is different from this D. You know, it could be this D is a subfolder of this one. So let's instead try to print the whole path. So we can do like this. Now we have this unfortunate problem that the first one is called slash. So we get this extra double slash here. And one way we can fix that is just use a different convention like this, which I think is fine. I mean, the point is just that we have like a unique name where we can distinguish different absolute paths. Now, another thing, the next thing we need is that this dot dot operator, you can call it, is supported. So I'm actually gonna add a different pattern match here, where we specifically look for that. And if that is the case, we simply call pop. Let's see if it will complain. It doesn't complain about that. But now, importantly, you can see here we will go to the root, we will go to A, and then we'll go to E inside of A. Then we will pop one. So go here, we'll pop another, we go here, then we go into D. So now we have the correct structure here instead of just like one long string that we had before. So let me also remove that one. Let's put it back in and instead write Merry Christmas. Okay. So this is basically how I want to handle these commands using like this type of pattern. So let's add the other patterns. Now if we just get an ls, we don't actually want to do anything because it doesn't tell us anything. Now if we get a dir with a name, what does that mean? It means that well, first of all, it means we just called ls, and actually this should be like that because there's a $sign in front. If we get a dir with a name, it means we've just called ls, and and inside the current folder where we're at, there is a directory named A. And then we need to do something. Another thing that can happen, let's put to do. Another thing that can happen is we can get a size and then a file name. And again, something will have to happen. So we need to have some kind of data structure where we can store the fact that the directory with this name is a subdirectory of the current directory, and that this file with this size is a file in the current directory. And the way I did that when I solved this was using a hash map. So, or a dictionary, or whatever you want to call it. So let's make a hash map, and we will call it the file system, and it will be, let me see if I can write this correctly. So we want this to be a hash map from the full folder name to something. For now, let's call it string just to check that the way of writing this is correct. Right, so it wants this. It's a lot of warnings, and it panicked at to do. Okay, great. So basically, I don't want a string here because it'll be too much work, or like we can do better than that. So let's make an enum that we will call. Should it be called file? Should we call dir? No, it should be called something else. Let's call it element for lack of a better term. And it can either be a directory, which will just have a name, or it can be a file which will have a name and a size. So there we go. So now I want the file system to have a string and point to an element. So now we can implement this down here. So let's say full dir name let's actually say like current dir is the dir stack joined with something. Here it will just, we'll just keep using the dash. And then we can make the full name, which is, let's format it like this. It's the current dir. Actually, we should be able to put that in here. It's the current dir with the name. And then we add it to the file system. So I actually have the documentation documentation for HashMap here. And let me see how you insert it. If the map did not have this key present, okay, we don't care about that, so we just insert. Actually, maybe we do care about that. So let's insert for this full name. We will insert a string. For the current dir, we will insert not an element, but a dir with the full name. And we will say if let some value equals this. This means that this current dir was already, well, that we need to handle that actually. So it is it's actually incorrect to say that we only have one element. We actually need a vector of elements. And then to handle it, we can first like get the value out. Yeah, so let's try that. So like, let's say current contents is file system get current dir, and then depending on whether this is none, if it's none, we can just insert a vector with one element. And let me zoom out a little bit. And if it is something, then we want to do something like this. Let me remove this. And there is some kind of formatting error because this is not a semicolon. Okay. Let's see if it actually works. And right, we need to say use element. Okay, and when we get things, it needs just a reference. Well, we can easily do that. And here expected right. So when we push, it doesn't return. So let's do this. I'm not really expecting this to work, but let's try it nonetheless. Okay, this is interesting. We're getting a reference to the contents, which is what it's saying here. Expected struct vect found reference to vect. So perhaps it's enough just to pull it out and then push. Let's see. Right, so because this is, I just want to ignore that. Doesn't really matter to us, so let's do it like that. And now it's complaining about unused variables, and there is an error. Cannot borrow contents as mutable as behind. So we have to probably say get mutable. Get mutable. And now it runs. So when we're done here, let's just try to print we need the debug. Let's print the contents of directory A. Let's see if that works, and we'll unwrap it. Why am I saying contents? I meant file system. An element cannot be formatted, so I need derived debug. Again, some warnings. Great, so now we see that this directory should contain a directory called E. So we'll do, we can check that. CDA, ls, there's a directory called E and no other directories. We haven't implemented the files yet, so that's good. So this is one way to do it. Now let's implement the file system. And here it is. So I again take the current directory, I take the current contents. And now we have to take this size, which is a string, and pass it to an integer or a usize. And then I make the file, which has a file name and a size. And then I do the same trick. I see, do we have something already in this folder? If we do, then we just, if we don't rather, then we just insert a vector with one element, otherwise we push. Let's see if it runs. It does not run. And that's because this one has to be converted to a string. So here we go. Now now we can see, great that we left this intact. In the folder A, which is inside the root, we should have another folder called E. We should have a file with this size, a file with G, a file F with this size, a file G with this size, a file H.lst with this size. So that is exactly what we see over here. So now I think we have everything in place. Let's remove this print. Now when we go through, first of all, we have this undo functionality using the stack, and we store all the information we find in this hash map as we go along. And the structure of it is this like pattern matching approach, which I quite like. But now let's actually do the assignment, which is find all the directories with the total size of most 100,000 and calculate the sum. So let's say we have calculate folder size, and it should have a folder, which is just a name, and we need the file system, which is should be a reference to this hash map thing, a string and vector of elements, and it should return a usize. Let's check that the compiler likes this. It does like it, but it is just complaining about unused variables. Okay, so to do this, let's first get the contents of this folder, and then if there's no contents, actually let's say if let sum contents equal contents. Actually, we can even further reduce it like that. Then we do something. Otherwise, let's return 0 because it's an empty folder. And then we need to say for element and contents. Then we have to match on what type of element it is. If it is a file with some name that we actually don't need and a size, then we just return the size. Or rather, let's do like this. We increment total size by the size. If it is a directory with some, and crucially right now this is the full name, then we recursively call this function with the full name and the file system. So this should be okay because we are using the full name, so we don't risk there being any kind of infinite recursion, assuming that file names within a directory are unique. But for example, if we use just the local name, then if D had a subfolder named A, we could end up in the situation where we like jump back to A and whatever. So we use the full name to avoid any infinite recursion, and we know it will eventually end up because it will eventually end up in a case where there's no more subfolders because the content is finite. So this should be okay. And now we can do something. Now we need to kind of loop over the folders. So let's see, there should be a function for that. There's something called keys here. An iterator visiting all keys in arbitrary order. Iterator element type is something something. Good, so let's total size under 100K. Let's just say total size is 0, and again it's mutable. And then we'll say for key in file system dot keys. Let's get the folder size. And I think we're gonna run into a problem right now because now we're asking for a reference, but there's already a mutable reference living in this scope from up here. But let's deal with that when we come to it. Okay, so the folder size, and if the folder size is less than 1, 2, 3, then we want to add it to our answer. Otherwise we do nothing. And then we can print here the answer, total size of folders less than 100K in size. Let's also get rid of that one. Oops, I wrote 4 twice. That's a good sign. And of course, here it's not just calculate, we should say total size plus equals this. And right, so once we have calculated the size of this folder, then we have to return the total size. Okay, actually it did not mind this. I thought there would be a conflict with this mutable reference, but there wasn't. Okay, total size of folders less than 100K in size. Let's check that that is correct on the test input. 95437, that's correct. And let's now also check that it works on the actual input. 1783610. Great. Now for part 2, we need to do something similar. Let me just remind myself. Right, so we have to like free up space now. And I think we will not write a different function. We will just like call this one solution or something instead. Let's go into main and fix that up. Like solution. Okay, so let's say used size is the folder size of the root, the file system, and we need unused space of this much, which means that what do we need free? We need 30 million. Minus the free space. And what is the free space? It is 70 million. Minus the used size. Okay, let's go back to the test. And just check that this calculation is actually correct. So we require this number, which is the same as that number. Okay. So then we have to loop through all directories and we have to find the smallest one that will give us enough. So let's make a list of candidates, or rather let's say smallest, for now it's none, and smallest size is also none. And then we will loop through the folders. We will again do this. And then we will say match smallest. If it's none, then this folder, then smallest can be equal to this folder, and smallest size can be equal to this size. Otherwise, if it is, actually let's do this. You know what? This one doesn't have to be an option. So let's just, we don't actually need to know what it is. We just have to check if the folder size is less than or equal to smallest size and the folder size is greater than or equal to the amount we need free. And if that is the case, then the smallest one that is useful is now that one. Smallest size is then folder size. We run that and there is a missing brace. And then let's print the smallest with some debug. And right, this one has to be some. And this one has to be folder size. Okay, so it's saying that the best candidate is /d, which is correct. We can also print, let's say, should delete directory with size, smallest size. And I'm just going to unwrap it. Okay. Now it didn't work. Great. So there is definitely some kind of bug where it's like a random. Smaller size, fuller size. Right, it's because, no, that shouldn't be a problem. In the first iteration of the loop, we should just always hit this one. It's because we also have to check if like folder size is eligible to be deleted. So it's like that. Now it should all the time give, D. Good. So finally, let's see if that works. What is the total size of that directory? It is 4370655, which is correct. Okay, so I thought that was an interesting problem because we had to use the stack data structure for undo functionality, and then we had to be a little bit clever about how we stored information. And also we had to write a recursive function, which is always fun. So maybe I will do more videos on this if I find some problems that are interesting, which I'm sure I will as the month goes along. But until next time.